and it is a little bit difficult to imagine. So how do you point out the vectors? Selectively, we are choosing the vectorial picture for the circular motion. So when object is at this particular location having some mass m, radial vector is directed outward from the origin as per the figure. Because of external agency, if it starts motion in the anti-clockwise direction, the initial tangential vector right now changes to the some other point B here. From A to B it changes. New tangential vector is represented like this. These two vectors will make an angle theta which is equal to exactly angle made at the center of the system, where this theta is called as angular displacement. And in the change in velocity, during this case, change in velocity from point A to point B, delta VAB is equal to root of VA square plus VB square minus 2VA cos theta. In the given figure, speed of the object is constant. Therefore, we can, upon solving this entire thing, we can write down V of root to make 2 common 1 minus cos theta we can prepare, which is equal to 2v, you can write down as sine theta by 2. This is the change in the velocity from here to here we can write down. Now during this case, this is the velocity vector, this is the radial vector. Now if these two things, okay, we'll try to give you result about angular velocity omega. You have to imagine this angular velocity omega cap in perpendicular to the plane. Perpendicular to the plane means this is a direction. This particular line are called as imaginary line is known as what? Rotational axis, called as rotational axis. Along the direction of rotational axis, omega is there. How to identify this one, sir? So simple, Nana. Let us try to use a right hand screw rule. Keep your right hand thumb in the rotating plane such a way that folded fingers will try to represent the direction of motion. In such a condition, if suppose this particular arrow mark will represent a folded finger direction, then thumb will comes in the upward direction. So therefore that thumb will try to represent the rotation axis direction. This is the figure what we have to be taken. No doubt that is in this upon sandwiching all these three frames, first one, second one to here, third one, we get a result that is Vt bar perpendicular to R bar. No doubt from these two cases, any point you can take, this will be satisfied. And R bar and omega bar both are in the perpendicular planes. Similarly, omega bar also perpendicular to Vt bar because these two are the opposite planes, sorry, perpendicular planes. And this is in the same plane, but both vectors are perpendicular to each other. So these are the three conditions what we will take care in the first imagination slide. In the second case, suppose object is moving uniformly. When object is moving uniformly, under such case, this is the value of Vt and this is the value of Vt. Any point you can take a tangential speed Vt. So all positions contains same Vt. That means all positions contains same speed. But here angular, radial acceleration or centripetal acceleration AC or AR, that is given by V square by R, always directed to the center. This is only the acceleration present on the system. Come to the second situation. Suppose if the velocity changes at that point only within a fraction of second, then called as accelerated object. During the acceleration process, what happened? Uniform becomes to the non-uniform circular motion. In the non-uniform circular motion, tangential acceleration, centripetal acceleration, net acceleration, these three are exist in the same plane. AT, A, AC, they are all called as coplanar vectors. They are all exist in the same plane, coplanar vectors. And the plane of vector is nothing but rotational plane only. They exist in the rotational plane only. Where object is rotating, in that plane only these three vectors are there. Therefore, net acceleration is given by A is equal to, you can write down as AT bar plus you can write down as AC bar we can write down. Further, the magnitude of net acceleration is equal to, you can write down as AT square plus AC square you can write down in the given case. No doubt that is, what is the value of AT? So VT is equal to, we can write down as what? Omega bar cross R bar we can write down. Upon differentiating by time, V by T represent what? Velocity by time, nothing but acceleration, is equal to omega by T is nothing but what? Alpha bar cross you can write down R bar. So magnitudically all are perpendicular only na. Therefore you can write down as AT magnitude is equal to, you can write down as R into alpha you can write down, because theta is 90 degrees here between them. Now, okay. However, in the given problem, we substitute all the parameters here. We have the net acceleration given by, net acceleration is equal to root of alpha into r whole square plus v square by r whole square we can write down. This is the net acceleration acting on the system. If suppose at this particular case A is a resultant acceleration makes an angle of theta naught with respect to tangential, then tan theta naught is equal to, you can write down as AC by AT we can write down. What is the formula for AC? V square by R we can write down. What is the formula for AT? Alpha into R we can write down. We can write down as what here? V square by R square into alpha we can write down. This is called tan theta naught. Anyways, now if you try to multiply by mass with respect to acceleration, we get forces. Therefore, their forces also be along the acceleration directions only. Fc is called as centripetal acceleration. Ft is called as tangential. Sorry, Fc is called as centripetal force. Ft is called as tangential force. And these two forces are exist in the same coplanar, and then will give you rotation plane only. And the net force acting on system is equal to, you can write down as Ft square plus you can write down as Fc square, because they are at right angle to each other. Further, if you try to consider a next case, suppose a triangular shape of object is rotating in the anti-clockwise direction. What happened, in the same plane, velocity vector changes from one point to another point at theta degrees. Omega is taken care along the direction of the rotation axis, which is perpendicular to the plane. Centripetal acceleration always acts directed towards the center in this particular case. Now, in next case, in the given problem, let us try to consider, suppose if the number of rotations are increases means in this particular case AT and as well as VT in the same direction, whereas omega bar and alpha bar both are exist in the same direction. Now, if the direction of acceleration and velocity, angular acceleration and angular velocity are opposites, then number of rotations will become what? Decreases in this particular case. Anyways, now we have to remember some important conditions here. Already we studied, but a small consideration here, what we missed here. Ft dot Fc dot product is always 0. Why? Because Ft tangential force is perpendicular to that of Fc. Okay, that's why the dot product will be always equal to 0. Case 1. Case 2. Now in the given case, alpha bar and alpha bar parallel to that of omega bar, number of rotations increases, and omega bar is anti-parallel to alpha bar. In such a case, number of rotations going to be decreased in this particular condition. And further, by looking in this particular case, radial vector is always perpendicular to the, remember, third point. Radial vector is always perpendicular to omega bar, and it is also perpendicular to the alpha bar. That means r bar dot omega bar is equal to r bar dot alpha bar. All are going to be equal to what? 0. Let us try to take care in this particular condition. Thank you for watching my video. Please subscribe my channel for further updates. Jai Hind.